Okay, students, last class what we have discussed, we have I think completed these important non-SI units, and I have given some homework. So have you done? Particularly the unified atomic mass unit. I have asked you to do. So have you done it?
Yes, sir.
Okay. So who can define what do you mean by unified atomic mass unit?
Sir,
Nobody.
one unified atomic mass is defined as the mass of an atom which is equal to the 1/12 the mass of carbon atom.
Unified atomic mass unit. So, so unified atomic mass unit is equal to it is the symbol is U. So one U is equal to 1/12 of mass of one atom of carbon 12 isotope. Okay, 1/12 of mass of. Is the video visible? Are you able to write? So all of you write this. One U equal to 1/12 of mass of one atom of carbon 12. Clear? Okay. And carbon 12 isotope, the mass number is what? Okay, mass is what? 12 gram. And how many number of atoms of carbon 12 has mass 12 gram? Avogadro's number of atoms means 6.023 into 10 to the 23 number of atoms. Then mass of one atom is what? 12 by
So 12 by 6.023 10 to the power 26.
yes. Hmm. So 1/12 of 12 by Avogadro's number. Hmm. Gram. And Na means Avogadro's number. Avogadro's number, and this value is equal to 6.023 into 10 to the power 20 022 6 10 to the 23. Okay, 6.022 10 to the 23. Uh, and if you so this means see one U is numerically equal to reciprocal of Avogadro's number when expressed in gram. Is not it? Is it clear? And if you substitute the value 1 by 6.023 into 10 to the power 23, this gram, and if you calculate the value, so it will be 1.66 into 10 to the power minus 27 kg minus 24 gram minus 27 kg. So 1 U equal to this much. Okay, a very small mass, but particularly used in atomic and nuclear physics. Is it clear? This unit is very popular, particularly for atomic and nuclear physics. Okay. So I hope it is clear to all of you what is one U.
Yes, sir.
Clear or not?
Yes, sir.
Okay. So now we are in a position to go for dimensional analysis. Directly we'll go for dimension. Will not waste time anymore. Dimensional analysis. Okay. Hmm? So what do you mean by dimensional analysis? See, I'm just giving an example. You see, who can tell me different units of energy? Being ICC students, you people have already studied in 10th class. Different units of energy. Hmm. Who can tell me different units of energy?
Sir, joule,
Yes, then.
calorie,
Hmm. Good. Then.
kilocalorie,
Sir, arc.
Yes, yes.
Sir, arc.
Or yes. Then.
sir, watt hour,
Okay. Kilowatt hour. Yes. Then. Another you have studied electron volt. Yes or no? This means you see energy is just a physical quantity, but it has how many units? So many units of a single physical quantity just leads to confusion. Is not it? Yes or no?
Yes, sir.
Which they show, see, these units are not useless. They are useful in a particular context, but but it is not good that one physical quantity having so many units. So to remove this confusion, to remove this discrepancy, people have developed a new technique, that is your dimensional analysis. So dimension means one physical quantity, one dimension. Do you follow? One physical quantity, one dimension. Energy means whatever energy it is. Heat energy, sound energy, electrical energy, whatever energy, but it has only one dimension. Do you follow? But
Yes, sir.
unit is different. You are telling heat energy, calorie, and electrical energy or atomic energy, EV, nuclear energy, mega electron volts, so many things. So now it is clear why dimensional analysis is introduced. Okay. So then how to write the dimensions? Hmm. How to write the dimensions? Now see, you have to first express a physical quantity in terms of fundamental quantities or units. Okay. And the powers that appear above the fundamental quantities or units, these are known as dimensions. For example, let me give some examples so that things will be better. All of you understand this. Hmm. Just see one example. Suppose example one. Suppose okay. Before we go for this, first let me clear. So who can tell me all the seven fundamental units, physical quantities and units, corresponding units? Hmm.
Sir,
All
mass.
the seven.
Sir,
Hmm.
Sir,
mass
mass
kilogram.
kilogram.
One girl is telling okay. You say yes.
Sir, length length meter.
No, you have to I answered many questions. Let the girl say.
Sir, length for meter.
Hmm.
Then time for second.
Yes.
Electric current for ampere.
Yes.
Luminous intensity for candela.
Hmm. Good.
Temperature
Then.
for Kelvin.
Hmm.
Sir, one more
Bacterial,
was there. I don't remember.
bacterial
Sir,
for
amount of
Kelvin per
substance
temperature.
mole.
Amount of substance, the physical quantity, and unit is mole. Okay. Okay. So all these are 7 fundamental units. So what you do, we normally express them in terms of fundamental quantities, but in some cases units are used. But the idea is first you just use the given physical quantity, sorry, express the given physical quantity in terms of fundamental quantities or units, and the power that appear are known as dimensions. Hmm. Okay, I am just writing one. Suppose area. So what is the formula for area? Who can tell me in general? General formula for area:
Sir, length into breadth.
length into breadth. So length and breadth are same physical quantity, that is length, is not it? Unit wise. Breadth also meter, length also meter. So dimensional formula of area we write like this: A square bracket. A is enclosed inside the square bracket, and for length L1 and for breadth also L1. So it becomes L2. Okay. So dimensional formula of area equal to L2 square bracket. Is it clear?
Yes, sir.
Okay. So area over. Then second example, easy example, volume. So what is the formula for volume? Length, breadth into height. Is not it? LBH. Length into breadth into height. Agreed or not? So volume dimensional formula will be length is L1, breadth is L1, height is also L1. So it is L3. Is not it? You understand? And you see 3 is the dimension of, and the square bracket everything is dimensional formula. And if you include LHS and RHS, this is called dimensional equation. We'll say this later on. But is it clear? Area, volume, clear or not?
Yes, sir.
Okay. Then who can tell me what will be the dimensional formula of density? So density formula first tell me. Density equal to
Sir,
rho
mass by
equal to
volume.
rho equal to m by v. So we give the symbol rho for density. Rho, RHO. RHO, rho for density. Rho equal to m by v. Then who can tell me the dimensional formula for rho? All of you write in your copy. Dimensional formula for rho equal to mass by volume. Mass the physical quantity itself, so m1, and volume just above we have done. What is this? L3, is not it? So the final becomes m1 L minus 3. Is it clear?
Yes, sir.
Density rho equal to m1 L minus 3. Okay. So all of you understand? I hope all of you understand this. Understand or not?
Yes, sir.
So only one student is telling yes sir and responding. What about others? Why you people are not responding? You should say na. If you don't understand, say simply sir we don't understand. Please repeat or anything. Are you able to understand? Others please respond.
Yes.
Yes.
Yes, sir.
Okay. Then you write another one: area, volume, density, finish. Then you write velocity. So velocity formula is what? Velocity is displacement by time. Yes or no? S by t. So displacement by time. Then what will be the dimensional formula of velocity? S is L1. Yes or no? Displacement is L1 and time is t1. So it becomes L1 T minus 1. Is not it? Do you follow?
Yes, sir.
Yes, sir.
Hmm. So velocity becomes L1 T minus 1. Okay. So velocity over, then I will at first write 10 dimension of 10 physical quantities, and I will give you to write the dimension of more 5 physical quantities. So velocity, then come acceleration. So acceleration, what is your formula?
Sir, velocity by time.
Velocity by time. So A equal to V by T. So dimensional formula will be very easy because velocity just we have written. What is the dimensional formula velocity? L1
Sir, L1 T to the minus 1.
L1 T minus 1 and divided by T1. So the final expression becomes L1 T minus 2. Okay, L1 T minus 2. Is it clear or not? Acceleration becomes L1 T minus 2. Okay. Then 6 force. So what is the formula for force?
Mass into acceleration.
Mass into acceleration. So only one student is telling. What about others? Hmm. Force into force is equal to mass into acceleration. All of you write the dimensional formula force and raise your hand. I want to ask you. All of you write the dimensional formula force as I have discussed. Then raise your hand. Hmm. Many students have raised your hands. Okay. Divyasa Naik.
Yes, sir.
You say
MLT minus 2.
how? Explain.
Sir, formula for mass will be m and
Hmm.
acceleration is LT minus 2. So it will be m minus 2.
Yes. So force is equal to mass into acceleration. Mass itself is fundamental, so m1 is kept, and acceleration we have already calculated L1 T minus 2. Just above we have written acceleration dimension is L1 T minus 2. So the final expression becomes m1 L1 T minus 2. Is it clear? Can I understand or not? Okay. Okay, good. Then let me. Hmm. Okay, so now you lower your hand. Next question will raise your hand. Okay, question force. So you have calculated. So work. So what is your formula for work? Force
Force into
into displacement. So then what is the dimensional formula of work? Raise your hand. You write and raise your hand. You write in your copy, then raise your hand. Okay. So Sushri Tanmaya.
Yes, sir.
Say what will be the dimensional formula of work?
Sir, force is mlt minus 2 and
Yes.
displacement is L1. So,
Okay.
dimensional formula of work will be m1 L2 t minus 2.
Yes, very good. M1, L2, T minus 2. Okay. So now you people are in a position to write the dimensional formula. Means if you know the formula of the physical quantity, you can easily write the dimensional formula. Okay. Now I am giving you five more physical quantities. All of you write the dimensional formula and then raise your hand. Okay. So question one. Write down the dimensional formulas of the following physical quantities. The following physical quantities. Okay, following physical quantities. So first one, okay, mm, A is kinetic energy. So kinetic energy, and B is potential energy, and you have to show how we get it, and that is also important because you are learning this now. So you cannot directly say. You have to write the formula, then write the dimensional, write the equational formula, then dimensional formula. Like kinetic energy, potential energy, then pressure, then momentum, then so kinetic energy, potential energy, pressure, momentum, then mm, then sine theta. Okay, these five physical quantities, all of you write, then raise your hand. Understand? Okay, so have you done only the five physical quantities? Hello, are you able to write?
Sir, doing sir.
Okay, okay. Okay. So far, four people have raised their hand. Uh, Five. Hmm. Okay. Anushka Sarkar, you say first
Yes, sir.
answer. Kindly
Sir,
put your hand.
yes, sir. First answer is M1 L2 T minus 2 because the formula of kinetic energy is half mv square where m is mass and v is velocity. So the L T minus 1 whole square. So like that answer will come.
Hmm. For mass m1 and velocity is L1 t minus 1 whole square. So the final is m1 L2 t minus 2. Okay, good. Okay. So next question. Hmm. Hmm. So what
Sir,
to
sir,
say? Uh,
sir, we won't write a half, half
ah,
M1.
no. When you write the dimensional formula, that numerical constants should be ignored. Numerical constants don't have dimensions. So half or anything numerical is there, that should be ignored.
Yes, sir.
Is it clear? Okay. Then potential energy, who has done? Anybody else? Potential energy. Potential energy formula is what? mgh. You have read na in 10th class. Potential energy is mgh. Is not it? Simeon, you say?
Sir, M will be M1, then G is acceleration, so L1 t to the power minus 2,
Yes.
and height is L1. So the formula is M1 L2 t minus 2.
Yes, very good. M1 L2 T minus 2. Okay, potential energy over, then pressure. Others are able to understand or not? Other students?
Yes, sir.
Okay. Then who will tell me the formula for pressure?
So can you take the copy little bit up?
Yes. Hmm. So who will tell me the formula for pressure?
So force by area.
Force by area. Then you write the dimensional formula of pressure. Force by area. Arnab Bharati.
Sir, it's M1 L minus 1 T minus 2.
How?
Sir, dimensional formula of force is M1 L1 T minus
Hmm.
2. Then
Yes.
divided by L2.
Yes.
Then we will get M1 L minus 1 T minus 2.
Yes. Good. Okay. Arnav has answered correctly. So pressure has dimensional formula as M1 L minus 1 T minus 2. Okay. Hmm. Then is momentum. So have you written, all of you have written the pressure dimensional formula?
Sir,
Yes, sir.
Okay. Is the video visible now?
no, sir, it's off.
Oh. Okay. Now it is okay.
Yes, sir, it's off.
Okay. So pressure is M1 L minus 1 T minus 2. Okay. Then momentum. So momentum, who will tell me the formula? Momentum.
The mass into velocity.
Yes. Again, T equal to M into Q. So velocity, I just write it in different manner. Okay. The same three, four students are responding. What about the others? No other student is responding. Huh? Ananya Rai, are you able to understand? Ananya, are you able to understand or not? No respond. Devraj, are you able to understand? Devraj, why people are not responding? Dipankar Das, are you able to understand? Okay, can you tell me the dimensional formula of momentum? Mass into velocity. Very easy. You try at least. So, dimensional formula of momentum. Yes, mass is m1, velocity is l1 t minus 1. So, the final formula becomes m1 l1 t minus 1. Is not it? The final formula becomes m1 l1 what? T minus 1. So, this is your final formula. Okay. So, momentum. Then, who has done for sine theta? Dimensional formula of sine theta.
Sir, I have done.
Sir, it is dimensionless because L1
L0
minus 1 will be L0.
What is the definition of sine theta?
Sir, perpendicular by hypotenuse.
Yes. The perpendicular side by hypotenuse. Then that is side by side. So L1 cancel out L0. So because it is a pure ratio, side by side ratio, is not it? So hence it has no dimension. Any pure ratio you understand? Pure ratio means ratio of similar quantities. Any pure ratio has no dimension and no unit also. But sometimes you impose some unit on it to make things simpler. But dimension they don't have. So that's why the interesting thing is some physical quantities have units but no dimension. Can you tell me what is that?
Sir, time.
Time has unit second, dimension is t1. It has both unit and dimension. My point is name a physical quantity. All of you write this question. This is your homework. Name mole has unit mole, mol, dimension mol, mole.
Sir, relative density.
No unit, no dimension.
Sir, refractive index.
No unit, no dimension.
Sir, mechanical equivalent of it.
Mechanical equivalent of heat has unit and dimension both. You see, you don't be in a hurry. You just write this question. Name the physical quantity having unit but no dimension. Are you able to write this question, all of you? Are you able to write this question? Name the physical quantity having unit but no dimension. Okay. So the question is name the physical quantity having no unit, having no
Sir, plane
having
angle and solid angle.
Sir, magnifying
how
power.
no magnifying power has no unit, no dimension. Name the physical quantity having
Sir, plane and solid
unit
angle.
but no. How?
Sir, because they are ratios of similar quantities.
So it is the ratio of arc length and radius length. So it will be L0.
Hmm.
So that's how it will be dimensionless.
Then how unit? So plane angle is as she told. What is the name, please?
Sir, Divyasha.
Divyasa. Divyasa, you see, as per the definition, plane angle equal to arc length by radius. So arc length is meter, radius is meter, meter cancel out, no unit also. but we are imposing a unit. That's why we say supplementary units. Yes or no? There are 7 SI units, fundamental units, but 2 supplementary units. We supplement, we are imposing unit on it. But formula wise, it should have no unit. But we are imposing that plane angle unit is radian, solid angle unit is steradian. That's why they have unit but no dimension. So the answer is correct. As Divya sir told, answer is plane angle or solid angle. You can write anything. So now the physical quantity having unit but no dimension. Okay. Okay. And sine theta also, I have already told sine theta equal to perpendicular by hypotenuse. P by H you are writing. So sine theta dimension equal to perpendicular L1, hypotenuse L1. So it is L0, no dimension. So all trigonometric ratios have no dimensions. Is it clear? So all trigonometric ratios have no dimensions. Clear? Understand or not?
Yes, sir.
Okay. So again, I am giving you some more homework. Question number 3. I just give you more 5 physical quantities and you write down the dimension of that. Then next class we will discuss. So write down. You see, I am planning one thing for Thursday. Thursday we are having 2 periods. So one is 11 to 11:45. Then it is 12 to 12:45. Another period. Is not it?
Yes, sir.
Yes.
Yes, sir. But all other days it is 11 to 11:45 every day. Huh? Okay. Then I am planning that on Saturday, since we have 2 periods, one period I will teach definitely first period, and second period we will either solve some questions or we will have a some test. I think means discussion. Test come discussion. I will not continuously give you 25 questions like that. I will just give you 5 questions. I will give you 2-3 minutes or 5 minutes. You solve it, then we will discuss. Then more 5 questions, then we will discuss like that. So I think it will be better because continuously teaching for 2 periods, you will also get bored and also you may not understand the concepts thoroughly. So better one class I will teach, other class we will discuss questions. Or after covering some portions, we may have a surprise, sorry, class test type things or different things. Not test because the online class what test. We will just discuss questions. Okay.
Yes, sir.
Okay. So now the question is write down the dimensional formulas of physical quantities. Dimensional formulas of the physical quantities. Okay, of the following physical quantities, of the following. Okay, some physical quantities, even if you don't know the formula, you can know the formula from the book or others. I am not giving too big or very new physical quantities. First is refractive index. Second is relative density. Third is optical power. Not mechanical power. Optical power means power of a lens, mirror, etc. And fourth is optical density. Fourth is gravitational constant. gravitational constant, and fifth is centripetal force. Okay, these 5 questions I have given. So all of you write, and next class means tomorrow we will discuss this and discuss applications of dimensional analysis. Okay. See, in our syllabus for this chapter 1 to be completed, we have 3 more applications. But these applications are important. It will take at least this entire week will go.